Welcome again to my YouTube channel. I'm Chydonns Daniel. This day we want to see summary of physical quantities and their dimensions. In the video before this, we discussed physical quantities, we discussed what it's all about, and we also discussed dimension and how to derive all the dimension of the derived physical quantities. Now, this day we want to see summary of all the possible dimensions we can lay hand on. So this video will discuss about 15 derived physical quantities and their dimension. As you can see on the board, we have up to 15 derived physical quantities and their dimension. So here are the derived physical quantities we have, then how it was derived, its dimension and SI units. In the video before this, we also said that we have many up to 7 fundamental physical quantities, and they are length, time, mass, amount of substance, temperature, luminous intensity, and so on. Now, we now said all these fundamental physical quantities have their dimension. For length, it is L. For time, it is C. For mass, it is capital M, and so on. So, look at the one of derived physical quantities. We have 15 of them before us, and want to see their respective dimensions. For area is length times length, L square, because it starts with L, then dimension is meter square. For volume is length times length times length, then L raised to power 3, because there are 3 L meter cube. Yes, because SI unit of length is meter. Other units of length are centimeter, millimeter, and others. Now, for density, mass over volume. What is volume? Length times length times length. That means meter over volume. That is days, SI unit. Speed and velocity. Speed, we just put this speed and velocity together. Why? Because they have same dimension, irrespective that they have different meaning. You remember that speed is a scalar quantity. Speed does not have dimension, but velocity is a vector quantity and it has dimension. So, but in the terms of their dimension, they have the same dimension, irrespective that one have direction while the other one do not have direction. That is, velocity has direction, but speed does not have direction. It only has magnitude, but no direction. Then, for acceleration is equal to velocity over time. And what is velocity? Displacement over time times time. Then, what is displacement? Dimension of it, length over time times time. Length will bring out L. Time is into 2, so a power of 2. This is the unit. Once you get this, L unit of it is M, unit of time is seconds. You package it well. For force and weight, mass times displacement over time times time. That is for mass times acceleration. Then we now say mass is capital M, that is the dimension. We now say displacement is length, time is into 2, t raised to power minus 2. Why we are putting raised to power minus is because time they are at the denominator. So because you are writing it at the numerator, you put minus from law of indices. Because you are bringing these 2 times up, you bring in minus to show that they were at the denominator before. So this is the SI unit. For velocity gradient, we say it is displacement over time times time. What is displacement? Length. What is time? Time. What is length? Length. Now, you will see that length will cancel length, leaving you with 1 over t. We have 1 over t, we have per second. For pressure gradient, we say pressure over length equal to force over area times length. Then, from there, force is meter. Force over area times length, the dimension is meter times length raised to power minus 2, time raised to power minus 2. Then the unit is kilogram meter raised to power minus 2 and s raised to power minus 2. Then for energy or work, force times distance, mass times acceleration times distance, because mass times acceleration is work or energy. So times distance, that is this distance, we have this to be the dimension. For pressure, pressure is force over area equal to mass times acceleration all over area, because mass times acceleration is force. So over area we have ml raised to power minus 1 s raised to power ml raised to power of minus 1 t raised to power of t raised to power minus 2. Remember, this is SI unit, that is not dimension. Okay, t raised to power minus 2. Then the unit is kilogram meter per second and kilogram per meter per second squared. Kilogram meter raised to power minus 1, second raised to power minus 2. So viscosity, force times length all over area times velocity. Yes. Now force, when you simplify this from mass times acceleration, force is mass times acceleration times length over area times velocity, it will be giving you ml raised to power minus 1, t raised to power minus 1, and this is the SI unit. Then for the one of energy density means energy over volume. Now note that whenever you hear velocity gradient, anything gradient, let's say they say OB gradient. OB gradient means OB over length. OB gradient means OB over length. Then pressure gradient will also mean pressure over length. Velocity gradient will also mean velocity over length. Note that whenever you hear velocity gradient means velocity over length, then you can simplify. Or whenever you hear pressure gradient, it means pressure over length. Momentum gradient, momentum over length, and so on. So note that as you want to derive their dimensions. Then for energy density, we say it's energy over volume, force times distance all over length times length times length. This is the dimension and this is the SI unit. For power, energy over time or work over time. What is work? Work is equal to force times distance. Then you now say all over time. Then you now say what is the dimension? ml squared raised to power minus 3. What is the SI unit? You have it. Then we have thermal conductivities. Thermal conductivities is energy times length all over time times area times temperature. That will be, the dimension will now be ml raised to power minus 3 theta raised to power minus 1. Because the dimension of temperature is theta. Then the unit will be kilogram meter second raised to power minus 3 and Kelvin raised to power minus 1. Kelvin because dimension of the SI unit of temperature is Kelvin. That is the SI unit of temperature. So this is a summary of what we have on physical quantities and their dimension. Remember, in the video before this, we were able to see how to derive all this. Some of these physical quantities you see here are already derived in the videos in my channel. So try to check my channel, check the videos in my channel and see how we derive all of them one after the other. So this is a summary of it. Thanks for watching the video. Please, if you enjoyed this video, don't forget to click like and click subscribe so that you see more of videos from Nwachukwu Daniel. See you next time.